Right, hello everyone. Feels like a long time since I've been doing one of these for you, and it might even end up being the last one, given how close we are to the end of term now. So we're going to talk about inequalities today. This is something that you're going to need going forward, that you're going to use again next year. So we'll make a start and we'll see how far we get today, and whether we can do anything else over the rest of the term. So inequalities, what are they? Well, we've seen them a little bit, I think, throughout the year. We've seen them a little bit when we looked at frequency tables, but basically an inequality involves a less than sign or a greater than sign, or less than or equal to or greater than or equal to. And you should be very familiar with those signs, those symbols, so let me just remind you. So these are the signs, the symbols that you need to be using. So this one here is a less than. This one here is a greater than. So this is how you say them. We'll talk a little bit about what they actually mean in just a second, although hopefully you're fairly familiar with them. And then this one is or equal to, so less than or equal to. And then this one here is a greater than or equal to. Okay, so you can see the little or equal to lines underneath. And basically they're a way of comparing two things. So an equal sign tells you that two things are exactly the same. An inequality sign compares the two and tells you which one is smaller, which one is bigger. Okay, so it's quite straightforward to use with numbers. So we can say things like 3 is less than 17. That's particularly true. 42 is greater than 6. And so on and so on. And you can even say things like, well, actually 3 is less than or equal to 17. It's not equal, but it is less than or equal. But you can also say, so 3 is less than or equal to 3 because it's equal to 3. Okay, so there's a subtle difference between the less than and the less than or equal to, which is quite important in a few cases. Okay, so what can we actually do with inequalities? Well, the main thing that we're going to do is we're going to define sets of numbers using inequalities. And a really good way to have a look at how this works is to use a number line. So here's a number line with 0 in the middle and numbers obviously getting larger positive to the right and larger negative to the left. So let's put some numbers on. So let's make this go up in 2s, 2, 4, 6, 8, 10, and go down in 2s as well. -2, -4, -6, -8, -10. And then there are all sorts of different sort of sets of numbers that we can define on that number line. So let's just have a look at a couple. So if we had a set of numbers that started here and then went this way, so this filled in circle here means it includes that point. So it includes this point. So if I say that is the set, we're going to call that set of numbers x. So all the numbers on this orange line, we can say are greater than or equal to 4. So if that's been represented by x, then we can say that x is greater than or equal to 4. Okay, it's or equal to because it's including that point. That point is filled in. Let's see what else we could do. We could have an open circle, which means that we are not including it, and then we could go to the left instead. And if I call that y, then you can see that y is all of the numbers which are less than -4. So y is less than -4. Okay. One more that we're going to have a look at, which is that we can do these two regions, the orange one and the pink one, they're infinite, right? They're going on forever and ever. This orange one is getting bigger and bigger and bigger, so you can choose any number bigger than or equal to 4. So you could go for 1,000,000, you could go for 1,000,000,000, 1,000,000,000,000, and so on. You can get as big as you like. And the same with the pink one, it's getting smaller forever, so you can get as small as you like. But we can do something like this. So if I had a closed circle here, and then a line goes up to maybe here with a little open circle. So that's a finite region. It's contained between two numbers, does not go on forever. And we can define that as well using an inequality. So it's obviously the lower end here is -1. Let's give this a letter. Let's call this z. and the upper end here is 8. So z is kind of between -1 and 8. Now we can say that z must be less than 8, okay, strictly less than, because that's not a filled in circle, so it cannot be equal to 8. But we can also say that z is, I'm going to write this over here now, z is greater than or equal to -1, okay, because it's everything to the right of -1. So that also is true. And what we can do with these double-sided inequalities is we can write them as a single sort of mathematical sentence. So if z is greater than or equal to -1, then what that means is that -1 is less than or equal to z. I'm just kind of reading this mathematical sentence backwards, right? -1 is less than or equal to z. We just check that, just pick a value that's within this blue line. So let's say this one here, 2. Well, -1 is indeed less than or equal to 2. Yeah, so if you pick any number that is within that blue line, it is going to be less than, oh sorry, -1 will be less than it. So we can fill that in as -1 less than or equal to z less than 8. And these sorts of things, these kind of double-sided inequalities, they crop up all the time. You'll see quite a lot of them over the next few years in your study of maths. And that's what they mean. They mean this kind of two-ended set of numbers. All right, so now we know what those symbols mean, what they're all about. We're going to look at the main bit of this lesson, the main thing that we're going to be really worrying about today, which is solving inequalities. So what does it mean to solve an inequality? Well, if you've got like the inequalities that we had on the previous slide, so something like x is less than 8, it's really easy to just go, well, I know what values fit into that inequality. I can have 7, I can have 6, I can have 5. I don't even have to limit myself to whole numbers. You can go for 7.8, you could go for pi satisfies that inequality because it's 3.14, etc. So there are a load of solutions to that inequality, a load of numbers that satisfy that inequality. Okay, we can make a slightly more complicated inequality that we could go for something like 2x plus 4 is greater than or equal to 10. Now, in order to solve that inequality, in order to think about some values of x that work for that inequality, we might need to do a little bit of trial and error. So we could say, well, what happens if x equals 1, let's say? Well, if x equals 1, we get 2 times 1, which is 2, plus 4, and we want to know, is that greater than or equal to 10? Well, 2 plus 4 is 6, so no, that's not going to work. Okay, so we maybe need to make x a little bit bigger, so let's go for x equals 5. So if x is equal to 5, then you get 2 times 5, which is 10, plus 4, and that is obviously going to be equal, greater than 10, because 10 plus 4 is 14. So there's some point here between x equals 1 and x equals 5 where this changes from being a false inequality to being a true inequality. Okay, and the values of x at some point here between 1 and 5, they start making this inequality true. And we could actually probably just do a little bit of trial and error and figure out that if x is equal to 3, well, 2 times 3 is 6, plus 4, and is that greater than or equal to 10? Well, yes, because we're looking for greater than or equal to, so it works. So this x equals 3 is where it goes from being less than 10 to being greater than or equal to 10. So that 3 is very important. And what you can see, in fact, is that any number from 3 upwards, so 3, 4, 5, and so on, is going to solve this inequality. So this 2x plus 4 greater than or equal to 10 is actually exactly the same as saying, well, any value of x that solves that must be greater than or equal to 3. So actually that inequality is the same as saying x is greater than or equal to 3. So this, what we've just got to here, x greater than or equal to 3, is the solution to this original inequality. Okay, so this is the solution, and it's very, very similar to when you have an equation and you solve it. When you solve an equation, you get one value of x. when you solve an inequality, you get a whole series of values of x, a set of values that solve that inequality. And that's what we're going to be looking at today. But actually, there's not a lot more to it than this, because if you know how to solve equations, which you do, most of you showed me really well on your assessment that you know how to solve equations, then you can solve inequalities. Okay, so let's have a look at a couple of examples, and this gives me a chance to talk through a bit about setting out algebraic working as well. Then there's a MyMaths task to complete, and that's that. So 2 examples for you to follow, to write down in your notes, and then to use as examples when you're doing the MyMaths homework. So let's go for that example up above and see how we would actually solve it algebraically. So 2x plus 4 is greater than or equal to 10. Now we're going to work in exactly the same way as we would if this were an equation. And what that means is do the same thing algebraically on both sides. So the same algebraic operation. And we're trying to get x on its own. So the first thing we're going to do is we're going to subtract that 4 from both sides, which leaves us with 2x greater than or equal to 6. Okay, so I've subtracted 4 from both sides. And basically what that's saying is if 2x plus 4 is greater than or equal to 10, then 2x must be greater than or equal to 6. So that kind of makes sense. And then again, our final step, algebraically, we're going to divide both sides by 2 to come up with a final answer of x greater than or equal to 3, which is exactly what we got up above, just by the kind of trial and error solution. So it is exactly the same as solving an equation. There's no difference at all. You don't need to rewrite this as an equation. You don't need to worry about that. All you need to do is make sure that this inequality sign does not change. Okay, so look at that. It is a greater than or equal to all the way down, and then we end up with a solution which is x greater than or equal to 3. I'm going to have a look at one more example, which is, it goes through exactly the same sort of process, but we're going to have x's on both sides of the inequality sign here. But again, it works in exactly the same way as our equations, which have x's or unknowns or whatever on both sides. Okay, so we're going to go for, let's say, 5x minus 3 has to be less than, let's go for 8x plus 11. Okay, so we want to find a value of x, or all the values of x, the set of all values of x, for which 5x minus 3 is giving you a smaller answer than 8x plus 11. Okay, so how do we do this? Well, exactly the same sort of method as we did before. So we're trying to get x on its own. So if we want to get x on its own, that means we need to add or subtract some x's from both sides. Best thing to do is to subtract 5x from both sides so that there's none left on this left hand side. So we end up with minus 3 still on the left hand side is less than 3x plus 11. Okay, all I've done is subtracted 5x from both sides. So this 5x is gone and the 8x is now 3x. Okay, next step, we're going to try and get all the numbers on the other side. So that means we need to subtract 11 from both sides. So minus 3 minus another 11 gets us down to minus 14. A little test here of your negative number skills. And then that is less than still 3x on the right hand side. Final step, because we've got 3x on the right hand side, we need to divide both sides by 3, and so we end up with minus 14 over 3, so minus 4 and 2/3 is going to be less than x. Okay, so that's it, that's our final solution, because we've got a single x on the right hand side, and we've got a set of values which work. So we can pick any value for x as long as it is greater than minus 14 over 3. So we could go for minus 4, we could go for minus 3, we could go for minus 2, 0 would work, minus pi would work. Okay, so any number as long as it is greater than minus 14 over 3.